Hey folks, let's work on a couple problems on this idea of the probability of difference in means. So we're going to look at problem 9.48 in page 318. So the problem says, suppose that we have two normal populations with means and standard deviations listed here. So that's below. If a random sample of 25 are drawn from each population, what is the probability that the mean of sample 1 is greater than the mean of sample 2? Alright, so what is it that we're actually asking? So we're saying the probability that the mean of 1 is greater than the mean of 2. You could write that another way, say that the probability of the mean of 1 minus the mean of 2 is greater than 0. That way we can sort of deal with it in realms that we're able to handle. So let's look at the mean of 1 and the standard deviation of 1. And then the mean of 2 and the standard deviation of 2. Let's just copy this down for us. So the mean of 1 is 40, standard deviation 6, mean of 2 is 38, standard deviation is 8. Alright, so let's figure out sort of what we would expect to happen then. What would we expect? Well, what we expect is, again, it's right here, mean of 1 minus the mean of 2. This is the probability. This is what we're after. So what would we expect that to happen? What would we expect that to be? Mean of 1 minus mean of 2. Mean of 1 minus the mean of 2. Alright, so what is that? Oops. 2. Oh, okay. So, whoops. So what did happen? Or what did we sort of see happen? Well, it's just asking us what's the probability that the mean of sample 1 is greater than the mean of sample 2. So we're just greater than is greater than 0, right? So we effectively write greater than 0. Right? Or we could just type in 0. Let's type in greater than right here. Greater than 0. Right? This is what happened. This is what happened. This is what we expect to happen. So all we need now is a standard error, right? In fact, before we do that, let's draw a little picture real fast just to help us see what's going on. Alright, so here is the distribution of the difference in means. In this little thing, mean minus 1 minus mean minus 2, it's normally distributed just like any, just because of the central limit theorem tells us that it is. Our mean is what we expect is 2. We expect it to be 2. And we're asking what's the probability of it being 0? So 0 is over here somewhere. And we want it to be greater than, right? So that's this side. Woo. Greater than 0. So right away we can tell that this is not a bizarro world problem. It's the same type of problem, but that it's going to be it's not going to be like really small. It's going to be pretty big, right? Because most of the time 1 is bigger than 2, what we're saying. So we're going to say, well, what's the probability that if I take a sample of each of these? So by the way, let's insert a little thing here. Well, that's fun. And say, what's our sample of n of 1? Well, the sample of both of these was the same. I think 25, right? Sample 25, yeah, 25. Let's do the same thing here. This is fun when I insert a row, it stretches out my picture. N of 2 is also 25. Alright, so the final thing I have to do is do the standard error. So the standard error is kind of crazy for this stuff, but not too much. It's equals a square root. And then I'm going to put a couple parentheses, right? Because I want a square root over the entire thing, but inside I have sort of two little fractions, if you remember. And the equation is something like a standard deviation of 1 squared. So I put caret squared divided by n of 1. Right? That's one parentheses. That's like one sort of fraction. Add, and then within another parentheses, the square root of 2 squared divided by n of 2, which is also 25. Close that. So now I have sort of one fraction, and then that whole thing, I want the square root of all of that, right? So I put the parentheses finally after all of that. So that's enter. So a standard error equals exactly 2, which is interesting. So we can actually sort of already eyeball what's going on here. So this 0 is exactly 2 standard deviations away from the mean, this direction. Alright, so we should know that that's going to be a pretty big chunk over here. So let's find it. So norm, well, first of all, we want the right side, so it's going to be equals 1 minus norm dist, right? Our x is what we got, right? What did happen? 0. What did we expect? Right there, 2. Our standard deviation is really a standard error, there, and 1. Something weird happened here. There we go. 0.84. So 84% is over here. Alright, so that's that problem. So these are really pretty simple problems. The hardest part is getting the standard error thing figured out, but it's really not that big of a deal. I did it again. So I answered 9.48 in the tab of 9.52. Sorry, it's been a long day. Alright, so let's do 9.52 then. So this is a word problem, so this one will probably be closer to what you have to do in your homework. So, a professor of statistics noticed that the marks in his course are normally distributed. He has noticed that his morning class averages 73% with a standard deviation of 12% on their final exams. His afternoon averages 77% with a standard deviation of 10. What is the probability that the mean mark of our 4 randomly selected students for the morning class is greater than the average mark of 4 randomly selected from the afternoon class? So what's asking here? So let's see, the probability that the average of morning, right? The average of morning is greater than the average of evening or afternoon. And we can rewrite this. In fact, we're always going to sort of do this. That this should be rewritten as probably we just sort of subtract there and say that that is greater than 0. Right? So see a pattern. This is sort of how we answer these type of questions. So that's what we're after. All right. So let's just copy down some things. So here's morning. Let's see, mean, standard deviation, and then n. And then here we'll see afternoon. And mean, standard deviation, and n. So in the morning, the mean was 0.73, standard deviation of 0.12. And we're going to take a sample of 4, right, for each of these. 4 randomly selected classes. In the afternoon, it's 0.77, the standard deviation of 0.10, and also 4. Alright. Okay, so let's type in what we would expect. What would you expect? Well, we just follow this equation that we wrote down up here. Right? So we say morning mean minus afternoon mean, negative 0.04. But what did we actually see? Well, we saw 0. Right? Okay, so let's draw what this is going to look like. Okay, so we would expect to see negative 0.04. What we really saw was 0, which is over here somewhere. And the question is saying, again, what's the probability of something bigger than 0? We didn't really see 0, but we saw something bigger than 0, which is over here, right? Bigger than 0. Which is the same way as saying that the sample of the morning people outperformed the sample of the afternoon people. All right, so let's do this. So what do we need left to do this? Well, all we need is a standard error. Okay, and we know how to do this. We just did this crazy thing, but it's the square root, and then I put 2 brackets of standard deviation of 1 squared divided by n of 1. Close the bracket there, and then add from that standard deviation of the second. Oops, I gotta put this in brackets, right? Standard deviation of the first one squared. Second one, afternoon squared divided by the afternoon sample size. So in this case, the sample size was the same for both of them. And then we close it all. 0.078. Okay, so let's think about this. This is actually a pretty big standard deviation, right? If we have 0.04, 0 is within 1 standard deviation, right? Because it would be, 1 standard deviation would be like 0.3. If I were to add 0.07, it would be 0.3 or something like that. So right away we could say, well, this might actually not be a small number. I mean, it's not going to be huge either, because it's less than 50%. It's going to be over here. But it's not going to be a teeny tiny number. So let's find this out. Equals norm dist, right? Oops, this is the right side, right? So 1 minus norm dist. X, what did I get? Well, I got 0. I didn't write this down anywhere. But 0, what did I expect? That guy. Standard deviation is a square root, or sorry, the standard error. And cumulative is what I want. 0.3, so 30%. So there's a 30% chance that even though on average our morning people sort of underperform the afternoon people, if I were to randomly select 4 people, there'd be a 30% chance that they would do better anyway. So it's not like complete bizarro world that might happen. Okay, so hopefully this helped with those last couple problems on your homework. Best of luck.